Hello, today's video is going to be from January 2021. It's the Pearson International Edexcel A-Level Physics Unit 5. And this was upon request on the YouTube channel. Someone asked if I could go through this. I happen to have the paper with me. So while I was relaxing on the balcony, I went through the answers. So hopefully it's a quick run through. I'll try and do it quickish, but it will be done in several parts just because I've got other things to do in between. All right, well, it was an old copy of the paper which I happened to have with me at the time, and it seems to be a little bit fainter than normal, but hopefully you can manage to see through it. So if you find this useful, you'll find this in the playlist with a section for Unit 5 just on the 21 and 22 papers all together. So it's very useful place to start your revision. My students in year 13 are currently revising for this unit, so it's an extra one that they're allowed to have a look at. I tend to ask my students to leave the most recent ones so we can do them as full mock practice exams, which is probably why you don't find the most recent papers playlists yet. They will be coming. Once my students do them as practice exams, more recent ones will be uploaded as well. Okay, so please bear with me. I realize that some of you are asking for the more recent Unit 5 papers as well, and they're on their way. All right, so use these 21, 22 papers first, and I think I've also made the October 2023 paper now public. So go in the playlist in the home page of the channel, go to the playlist and look for the Unit 5 playlists which are available. There's quite a few in the 2021, 2022 folder. I put them all together because I think it's useful finding them all in one place. Okay, the more recent ones have their own folders. Okay, so without saying anything else, don't forget to show your appreciation, like each video you watch. If you find it helpful, share it with your friends in your country, your school, where you're living, and help the channel grow. We're over 1,000 subscribers now, but it doesn't really mean anything in terms of YouTube unless we get enough people watching videos on a regular basis. Okay, so likes, shares, and subscriptions are the currency for YouTube and how you stay on top of the charts, if you like. So question 1 is multiple choice. We go straight through into reading it. A mixture of oxygen gas and nitrogen gas kept at room temperature. Okay, that's the context. Oxygen molecules, it says, are more massive than nitrogen molecules. Okay, they have more mass. So they want you to say which of the A, B, C, or D is the correct statement. Okay, so I've put a cross next to where it's wrong. So here, greater is wrong. The mean velocity of oxygen molecules is greater. Well, if they're more massive, their kinetic energy is proportional to the temperature in Kelvin. Yeah, so if they're more massive, their velocity will compensate for it by being less, not greater. And here it says the average speed is the same. Well, if the mass is different, the speed can't be the same for the same reasoning. And the third one, they want you to say that the mean kinetic energy, of the oxygen molecules is greater. No, the mean kinetic energy is proportional. That's what I've written at the top. The mean kinetic energy is directly proportional to the temperature in Kelvin. Okay, this will be somewhere on your formula sheet. So that's the underlying principle. So this one is wrong in terms of this equation which I've just highlighted. Okay, and then finally D must be correct. Let's just read through it. And let's put this one in green. The mean kinetic energy of the oxygen molecules is the same as the mean kinetic energy of the nitrogen molecules because they're in thermal equilibrium. And if you understand what I just explained, these two are the same. One in words and one as a mathematical relationship. Okay, hope that makes sense. Question 2. Scientists, it says, believe that some of the mass of our universe consists of dark matter. So this is Megan's talk. if you listened to hers or you were present when she did her presentation. Which of the following is true? So which of these A, B, C is true of dark matter? That's what we're looking for. Okay? So it absorbs all electromagnetic radiation. No, it's dark, so it doesn't absorb electromagnetic radiation. If it absorbed it, you'd expect it to also emit it. So there's two things. It does not interact electromagnetically. Okay? So this one is wrong. B is the correct one. So we'll come back to B. It exerts no gravitational force. Well, that's wrong. Yeah? Because that's how they discovered that there must be something which is providing a greater gravitational force than expected when they looked at the rotation of spiral galaxies. Now, this is just an idea that they came up with, saying there must be some matter which is dark or invisible, I think would be a better word, not detected, not detected in a normal manner, okay? And it's a form of antimatter. Well, it can't be a form of antimatter, because if it was a form of antimatter, it would annihilate some of the spiral galaxy, okay? So it would just lead to, it would not lead to the evidence that we're looking at. It will cause some other familiar things in physics, annihilation, for example. Okay, so you'd actually have less mass in the end. So we measure that we got more. But it emits no electromagnetic radiation, just the same as it doesn't absorb any electromagnetic radiation. It will therefore not emit electromagnetic radiation. So it has some kind of gravitational effect, or appears to, and it does not interact electromagnetically. So they call it dark because it doesn't interact with the electromagnetic force, and they call it matter because it seems to create some of the qualities that matter creates, like gravitational fields. Okay, hope that makes sense. So this is a really good question for you to understand the concept of dark matter better. Okay, so dark matter does not emit any electromagnetic radiation. You need to remember that. Make sure your notes are good. This is mainly for a student called Ali, who needs to make sure he has notes on everything. These are key things that get you marks in exams. The question 3, the penetration of matter by radiation depends on the ionizing power of the radiation. Now here they're talking about alpha, beta and gamma, so it's from the radioactivity topic. So I've changed the wording for myself when I'm reading it, depends on or is related to the ionizing power, okay? I just think that's a better way of wording it. Which of the A, B, C, or D is correct? So you're looking for the correct answer. And again, I've underlined the bits which are incorrect. So alpha are weakly ionizing. Now, alpha are the most strongly ionizing, and that's why, because they're strongly ionizing, they lose their energy more quickly, so they're less penetrating. Okay? B is the correct answer. So let's go through C and D first. Gamma is highly ionizing. Well, it is ionizing, but it's not as highly ionizing as alpha or beta. That's why it's highly penetrating, because it takes longer to lose its energy through ionization. So it can kind of go for longer without interacting. And ionization is an interaction with matter. Okay? And then it says gamma radiation is weakly ionizing, which is true, but it's not the reason why it's not very penetrating. Yeah? It's the opposite. Highly ionizing means it's going to be less penetrating. So let's use the same model of the green. B is the right answer. Why? Because alpha particles are highly ionizing, opposite of the answer in A. So they can only travel a few centimeters in air, because by the time they've gone through a few centimeters of air, they've lost all of their energy by ionizing X number of molecules, atoms, whatever is in its path in air. Okay, I hope that makes sense. So these multiple choice questions are a good way, when you're revising, of making sure you understand the basic concepts that you've been taught or been through. Now, learning happens after teaching stops, and it depends on how much you interact with material. And again, this is for Ali, Taleen. Make sure you go and do the donkey work. Okay, you've got to interact, you've got to discuss it, you've got to learn it again, you've got to think about it from different angles. Question 4. A metal bar is heated, then allowed to cool. Okay, so a metal bar, it then is relating temperature to radiation emitted. Okay, so here they're talking about radiation emission. So anything hot emits radiation, like a star. Now you've done this in the context of a star. The wavelength maximum, in other words, where the peak of the radiation in the curve that you've seen, which is called Wien's law. Go and look up Wien's law if you haven't got it in your notes. Yeah, occurs. Yeah, the wavelength at which the peak emission occurs is determined. Okay, so they've worked out what lambda maximum is, and the equation for it, yeah, for Wien's law, the equation for it is lambda max times the temperature is a constant, and they give you this constant in the data and the equations at the back of the exam. So go and have a look at it. If you're not familiar with it, you also need to make sure you're familiar with all the equations that you need to know how to use. All right, so the peak wavelength is then known. So now we've got to find out which statement, again, is correct, A, B, C, or D. Okay, so A is incorrect. Lambda max decreases as the metal bar cools. Okay, lambda max, remember that temperature, according to this formula, if lambda max decreases, the temperature must increase because they've got to multiply and give a constant. Okay, so which way will temperature go? The answer is temperature must go up in this case. Yeah? As the metal bar cools, there's a better way of doing it. As the metal bar cools, temperature goes down. The other arrow must go up. So as temperature goes down, oh dear. As temperature goes down, you've got to draw your arrows very carefully with this Apple pencil. So as temperature goes down, what's going to happen to the wavelength? The wavelength will increase. If lambda goes down, that means lambda must increase. Okay, lambda should not decrease. So this is where it's wrong. Okay, that's the wrong bit. And then B is the correct one, so we'll come back to it. C then says lambda increases as the metal bar is heated. If one goes up, the other goes down. Well, these are both going up, so it can't be correct. Increases, heated. If they both go up, that will not be correct. Okay? So this is wrong and this is wrong. And D says lambda stays constant. Well, lambda stays constant can't be right if the metal bar is heated. The heat is what changes the lambda max. So the only answer can be B. So B is correct. And here's some good revision notes for those of you who still haven't made your notes. Lambda max increases as the metal bar cools. Yes? And this is what the equation that I've shown you is. Lambda max must increase, yeah, as it cools. So temperature goes down, lambda max goes up. Now if you think about it, energy is related directly to frequency. Yeah, so the higher the temperature, the bigger the frequency in terms of photons. Yeah, so higher temperature will give, on average, higher photons energies, and that is inversely proportional to lambda max. So this will help you understand it. Question 5, it says a car is driven. I'm using the wrong function. A car is driven, it says, along an uneven road. So this car is, this forces the car into vertical oscillations. So it's to do with the oscillations chapter. Over time, the energy of the oscillations increases by a factor of 4. Okay, so the increase of oscillation means the amplitude goes up, and energy is proportional to amplitude squared. Yeah, if you think about it, because amplitude is related to velocity, kinetic energy. So think about that. And obviously that if the amplitude is increased, the energy of the vibrations increased, that means you must have hit some kind of key frequency when you're doing it. So the amplitude of the oscillation increases by a factor of what? So if the energy has gone up by a factor of 4, and the amplitude squared is proportional to energy, just like kinetic energy is squared. Okay, and you need to go and find out which equation explains this to you best, and I'm going to let you do that. Okay, so if you look at the equations at the back, see which equation would you use to prove that this is the correct answer. Okay, I'm giving you this fact that energy is proportional to the amplitude squared. Now go and look at the velocity equations and think, when is that going to be the biggest? So remember, when it oscillates more, it moves further away from the center or the equilibrium. And of course, it's going to constantly change between stretching and what is it? It's probably a spring system, the suspension system of the car. So as the spring oscillates, it changes between potential energy and kinetic energy. Yeah. So I think you've got to think of it mathematically and see if it makes sense to you. Question 6. Question 6 is the star Vega. Okay, so they're giving you the luminosity is 5 times the luminosity of another star, Altair. So I've written it like this, mathematically. And then they give you the distance of Vega from the Earth is 1.5 times the distance of Altair from the Earth. So again, I put it as an algebraic expression. It's now 1.5 times the other one. And then they've given you the intensity of the radiation for Vega. They've labeled it IV. And the intensity of the radiation from Earth for the other one is IA. And they want you to work out IV over IA as a ratio. So you've got to use the equation, which I have shown you. Here is a luminosity over 4 pi d squared. So for Altair, it will be this, the luminosity of Altair divided by distance from Earth. So this one, if you put it in, you just keep it as LA over 4 pi dA squared. Now the other one, we know the ratios. So the other one, the Vega intensity, will be 5 times the intensity of the dimmer Altair star. So I put 5 IA instead of the, I should have put LA, that should be LA, shouldn't it? Am I making sense? So this should be LA, 5 times LA, I just miswrote that. Yeah, so that is basically the conversion factor. Yeah, let's do that one again. So the conversion factor, this I've put at the top of this equation. Why does it keep losing its arrow? So annoying. All right, then at the bottom, instead of putting d squared, yeah, I put 1.5 dA squared. So I put that instead of that. Okay, so the two ratios have been changed. So then all the other terms will cancel. You know, when you divide the second equation by the first equation, IV, so you divide this one, this equation, by this one, all right, and you'll get the ratio of 5 to 1.5 squared, because all the other letters, LA, 4 pi d squared, will all cancel. So it'd be 5 to 1.5 squared, which gives you about 2.2, so therefore the answer will be D. Okay, C, sorry. And then the next question is question 7. Question 7 says a small satellite, mass given 245 kg, orbiting the Earth. The radius of the orbit is equal to twice the radius of the Earth. Yeah. The weight of the satellite in its orbit is about. Remember, then the weight on Earth is just mg, but the g gets weaker as you go away according to gm over r squared. And since the r is doubled, you can put 2r, where r is the radius of the Earth. So obviously the mass doesn't change, the universal gravitational constant doesn't change. The only thing that changes is you, instead of putting r squared where it would be g, it will be 2 squared less, so it will be the g value divided by 4. So that's what all you've got to do is 2,400 Newton roughly divided by 4. Okay, so if you just do it roughly, you'll see it's going to be, the answer is going to be 600. Okay, question 8, 2 stars, X and Y have the same surface temperature. So this time they're going to use Stefan Boltzmann's law, okay, where sigma is the constant, temperature is to the power 4, and A is the surface area. X has a 25% larger radius of X is 25% larger than that of Y. Okay, so I put the area will then be, so the radius is 1.25 times Rx. 25% larger is 1.25 times R of Y. You can then know that the ratio of the areas will be R squared ratio. So remember, when you're doing this, you just want to work out ratios, because what they're asking you to do is to look at the luminosity of X and the luminosity of Y and work out the ratios. These are very common questions in Unit 5. So you divide the luminosity of X by the luminosity of Y. They have the same temperature, so you can ignore that. So the only ratio in this equation above, the Stefan Boltzmann equation, the sigma and the temperature don't change. So the only thing that changes is A, and the area changes by a factor of 1.25, yeah? Squared is the ratio, and that's 1.56, which is approximately 1.6. So the answer is C. Okay, so these ratio methods, you need to get faster them so you can whiz through. The multiple choice gives you more time to finish the paper. Questions 9 and 10, it says refer to the same information. Yeah, it's an object performing simple harmonic motion. They've shown you the acceleration against time. And in question 9, they want you to look at the 4 graphs, yeah, that they given A, B, C, or D. Which graph shows the displacement, yeah, varying against time. Remember, acceleration is the negative of displacement, so you want the inverse graph. So where at the beginning A is 0 going down, you're looking for A is 0 going up. So the answer is A is the only one which has 0 and then going up. So it's going to be A. Okay, so it basically comes from this equation. That's the defining equation for simple harmonic motion. So once you've done that one, the second part of the question, looking at the same 4 graphs, it says which graph shows the velocity. If we know the acceleration graph, we want the velocity. So this time you need to know that acceleration is the gradient of the velocity graph. So one of these, if you take the instantaneous gradient of one of these graphs, you will get the acceleration. So I've put the answer is C. Now let's work from here because I need to scroll down. So we're looking for C. So over here you see at the beginning the acceleration is 0, yes, and then it's negative. So it goes from 0 to negative. Let's see if the beginning of the acceleration graph they gave us is 0, then negative. So it's C, and you can probably work out the rest yourself. I'm not going to go through any more of that. That's the 10 marks. Okay, I got 10 when I looked at the mark scheme. Okay, so the mark scheme, I'll go straight to it. Here's the mark scheme for January 2021. It's blurb about how they do the marking. Yeah, general marking. You can look at it and read it if you want. I never really read it. And here it is. So 1, 2, 3, 4, 5 with their reasoning. By the way, the IAL mark scheme is better than the AQA mark scheme. And the IAL mark scheme is better than the linear Edexcel mark scheme. They give more detail, just in case you are comparing your exam with others. There's the last 5, and that is the multiple choice questions done. Okay, so I'm going to go through the next question because it comes before the mark scheme. So the next question is section B. So these are structured questions. They usually start with shorter ones. This one's only 2 marks. Always show all your working, yes, to get the marks. The Earth is 9.5 times more massive than Mars. So again, it's like the multiple choice questions. The mass of the Earth is 9.3 times the mass of Mars. I don't know what I was writing first. I got a squiggle there. Sorry about the red as well. It's the only pen I had when I was asked to do this paper. The gravitational field strength at the surface. So again, it's G equals GM over R squared at the surface. The gravitational field strength at the surface of Earth, in other words, G, is 2.6 times greater than at the surface of Mars. Okay, so the GE is 2.6 times G of Mars. And we know G of E is 9.81. I haven't put the units in. Please, I apologize. Calculate the mean radius of Mars. So basically, we know the G's, the ratio of the G's. We know that the big G can just cancel out. And we know the ratio of the masses. So again, it's a ratio problem. Yeah, so you know that if you put G as the subject of the formula, as I have, if you make G the subject of the formula, it's got to be equal to GR squared over M generally. That means it will be equal to it for the Earth, and it will be equal to it for Mars. So once you've got these two, you can equate them, and you want to find out, the only missing one is the radius of Mars. We want to work out this. So you want to make this the subject of the equation. So this is what I've done. So the radius of Mars squared is equal to the ratio of the masses of Mars being at the top, and then the gravity term is inversed, and I'm sure you can work it out. Put all the numbers in and you'll get the answer, and hopefully it will be the same as on the mark scheme. Okay, so one for working out this, and one for putting the answer with the correct units, and then putting the answer in there to the correct number of significant figures. So over here they've given you 3 significant figures, but the ratios are given to 2 significant figures, so I would put 2 significant figures here. Yeah. Now let's look at the mark scheme to see what the answer comes out to. I didn't want to calculate it because it's actually one of my days off. So I did that one afternoon sitting out, enjoying the view. Okay, so there it is. The answer is 3.37 times 10 to the 6th. That's 3 significant figures. And you can see over here, they put the answer to 2 significant figures. All right, and that's how you get your 2 marks. So that's question 11 done. And I think I'm going to take a pause there because it's still one of my days off. So it's the spring break in school. So I've put out some GCSE videos. If you've got brothers, sisters, cousins, etc., friends who are doing GCSE, the GCSE we're doing is Edexcel International. So if anyone wants to go and look at them, the A-level videos get more views than the GCSE. So if there are anyone who wants to look at the GCSE videos to make them more popular, then I will keep doing them. Otherwise, I will continue only with A-level. Okay, and that goes for my students in my school too, I've told them. All right, so question 12, here's the mark scheme for question 12. Once we go through it, you can have a look, and then you can come back to this mark scheme whenever you want. Looks like we got specific heat capacity in this question. So here you see we got specific heat capacity. So the next question will be on specific heat capacity. And part 2 is about power And there's also the latent heat equations. So you've got specific heat capacity in the first part, and in the second part you've got specific heat capacity and latent heat coming in. So if you're my students, this is Mr. G who taught you this topic. And there's the end of the solution for question 12. So if you've done it, you can mark it yourself. And then there is question 12. Well, let's do it while we're on a roll, and then I'll have a pause. Okay? So it says a portable electric heater with a power of 280 watts used to boil water for a hot drink. Okay? The heater is placed into a cup of water. So it must be one of those immersion heaters you can just put in from the top. So obviously if it's boiling, the final temperature will be 100 degrees centigrade if we're at sea level. 165 grams of water in the cup, so it's quite a big cup. Yeah. A glass of water is normally 150 ml, a normal glass. The initial temperature of water, so the initial temperature of water is 12.5 degrees centigrade. So remember, you need the difference in temperature for heat capacity. And I remember doing this with my GCSE students, and I just boiled the kettle of water in the back of my lab where I actually make my tea. And we assumed that all the energy from the kettle is transferred to the water. But of course it doesn't. And we got double the value for specific heat capacity. In other words, half of the energy just went into the kettle and the surroundings. So this, remember, physics is a simplification of reality. Yeah? So when you're doing physics, remember these kind of statements are just so you can do the maths. Yeah? It's never that simple. Okay. The heater is used in London, yeah, where the boiling point of water is 100 degrees centigrade, because London is pretty much at sea level. Show that means mathematically. Show that the time taken for the water to reach temperature of 100 degrees centigrade is about 220 seconds. So that means they want you to do it accurately, 2 significant figures. All right, the heat capacity, they're given to 3 significant figures. And you know the energy is mc delta t, delta theta. Yeah, sometimes I use delta t. So delta theta is 100 minus 12.5. Probably get a mark for doing that. And energy is also power times time. So power times time is the energy. Why am I using power times time? Because they've given us the power. And they want us to work out the time. So in other words, if we know the power but we don't know the time, we can divide mc theta by the power, and you should be able to work out the time. We know the mass. The mass was 165 grams. Don't forget, you've got to change that to kilograms. Multiply by the specific capacity which they're given. So put all the numbers in correctly, you get your second mark. And then when I do it to 3 significant figures, I get my third mark and show that it's equivalent to 2 significant figures, 220 seconds. So nice, easy question. Question 12. And then part B, this has gone from the second structured questions. You can see now that the second structured question is 6 marks. Okay, gradually as you go through the paper, the questions get more difficult. So in part B, it says the same heater is used in La Paz, which is the world's highest capital city, where the boiling point of water is 87.7 degrees. So that's theta 2. So it then says, this time we are assuming the mass and the final temperature of the water are the same as in A, and the same heater is used for the same amount of time. So 220 seconds or 216 seconds. Yeah? And these are the controlled variables. So these don't change. What they want you to do is to calculate the mass of water converted to water vapor. So obviously for the same amount of time, it's going to boil more quickly. So you're going to have some of your time left to evaporate, yeah, the water. So E equals mc theta. We want to work out what is the energy required to boil the water in La Paz, yeah? So obviously it'll be less. And therefore, the time that you would need to boil the water, if we do exactly the same method as before, the only thing that changes is temperature change. It will only take 186 seconds to boil in La Paz. Yeah? So you got 30 seconds less if you compare it with the time that it took in London. So 30 seconds to spare, and that's how I did it. This is not how the mark scheme does it. I think my method is clearer. So the time difference would be 30 seconds. So you save 30 seconds of energy, and 30 seconds of the power use goes into now vaporization of water. You assume that the kettle would go off when it's boiling. It depends how it's controlled. Okay, so what would happen, the rest of the 30 seconds, the power 280 seconds, goes into the mass vaporization. So that's ml. So this is ml. So this time you want to work out m. We know power, we know time. The only thing we don't know is the mass that will vaporize. And when you put the numbers in, if you can follow my working, you'll get to two significant figures, an answer of 3.7 times 10 to the minus 3 kilograms to two significant figures, which I think is correct, and I've put it as grams, but you can do it either way. And that's the end of the first video. Hope you found that useful. I can't remember which student it was, but hopefully if you're subscribed, you'll be notified when a new video is uploaded. So I'll upload it in a few minutes, and I'll come back to doing the next question after a while. Okay, so don't forget to show your appreciation, like each video you watch, share the video with your friends, spread the word. I think the channel's doing quite well, and my students who come from other schools, they tell me that mine have more detail than other people's answers. Okay, so thank you very much for the people who comment and leave positive feedback, especially from my favorite student from Kenya, who has also found how to email me on through the website and has given me very positive feedback. So hopefully see you in the next video. Bye for now.